Week 8. My goodness, we're almost just about halfway through the semester now. Well, week 8 is the halfway point. After week 8, you have spring break, and then we come back from spring break, and I count that as week 9. I don't actually include spring break as a week. So I'll go week 8, and week 9 is the week right after spring break. All right, so what are we doing this week? Back to swimming. And you'll see that I just keep repeating these three sports: swimming, biking, and running. I take a little deeper dive on each sport, or a little different direction each time we go through that sport. This week and going forward, we're going to be looking a lot at application. So we're trying to really use biomechanics and be able to talk to people in the community. And this is really a big responsibility from you as a kinesiology student. Because as a kinesiology student, you're ultimately going to be an expert. You're going to have a voice outside of your degree once you have that, whether that's a bachelor's, a master's, or a PhD. And it's really important that you use that voice wisely and you take the ownership over using terms correctly, explaining them in ways that are understandable but yet still correct, and using appropriate units for terms. So and ultimately you're trying to help someone too out when you're talking with people. So this is a big responsibility, and that's where I'm going with this week. And you'll see it's heavier on some of the application videos. So what do we have? Back to swimming, and this time we're going kinematics. Remember what I said? I actually teach this class in reverse order from undergrad biomechanics. Undergrad biomechanics, I start in kinematics and I move towards kinetics, and then I do work energy power. In this class, I do almost the exact opposite. Almost. I start with kinetics, and then I add in work energy power, and then come back to kinematics. Kinematics are a big advantage to studying because this is what we see. And I talk about swimming and some of the movements associated with swimming, and trying to do it from a perspective where you don't need to be a swimming expert, but you need to understand some key elements of swimming and some of the mechanics that we see in swimming, and be able to recognize some of the kinematics and how they may be related to kinetics. So for example, I talk about how velocity is changing during the swim stroke. That means there's forces being applied to the swimmer in a way that allows for acceleration, either speeding up or slowing down while moving in a particular direction. So as you're looking at the kinematics, you really want to be thinking, what's happening with the kinetics? What are the propulsive forces? Where are they coming from? What are the resistance forces? Where are they coming from? All right, so really start trying to tie in the kinematics with the kinetics that we went through before. You might even want to go back and watch the swimming kinetics video and then watch the kinematics, or watch the kinematic video and then go watch the kinetics one, because we really want to understand the forces acting on the swimmer, because that's how we're going to be able to make some changes to swimming, right, by either increasing propulsive forces or decreasing resistant forces. All right, now I know I did buoyancy before, but I'm going to add in just a little bit more information on buoyancy, because it is sort of one of these weird forces. But it's a force that has a name, buoyancy, still units of newtons. And I go through the equation a little bit more in detail for this one. And I go through an experiment. I may have had, I should double check, but you may have already watched one of these videos already. But just a little bit more information on buoyancy. Sorry, the audio quality of this one right here is not that great. I'll have to redo that. And now here's where I actually have more time in this section, which is more the applied section for you this week. This is Ted Gerard and I talking in each of these videos, and we talk about open water swimming. We talk about swim injuries, which is his expertise. and then a little bit more in swim tips. And what I want you to watch these for is for looking for the application of biomechanics. Yes, there's a lot more information, but through these conversations, you'll start to see and hear us talk about biomechanics that are present during swimming. It's not the entire focus. And that's the other thing I really want to continue to reinforce. In order to really understand human performance, you need to have a perspective that is, it's much more broad than just biomechanics. Biomechanics is just one part. We got to know physiology. We need to know motor control, motor learning. We need to know injury information, injury mechanisms, how to prevent injuries, how to rehab injuries. And so we really need that big picture perspective of kinesiology. Now, I know there is not a single class that you take that actually wraps all your courses together into one course. That's almost what we're doing here. I'm trying to get us to think beyond or be part of conversations beyond just biomechanics, but it's a biomechanics class. So you got to keep coming back and really have your ear tuned to hearing the biomechanics terms. And I'll even challenge you as you watch those videos, every time you hear a biomechanic term that we've gone through, write it down. Make sure you know how to define it. Make sure you know what the equation is for the term, if there's an equation that goes with it, and what the set of units are. Again, if it's a parameter that has units. That's how you should be watching these, is listening for biomechanics. Have your ear tuned to that. At the same time, you want to really start trying to understand how you integrate information from all your different classes to trying to understand human performance. Okay, so semester project 8, going to pull together everything. All right, so we're about halfway through the semester. Well, you are halfway through by the time you watch this video.